So as mentioned previously, adding functions to your programming will indeed dramatically change how you do programming. And I know I said the same thing for conditionals, but it was indeed true back then as well. This should be a pretty major feature of most programs you write from here on out, because unless the program is going to be very small, it's going to be a very beneficial thing. So these functions are basically what we would say, I like to call repeatable. They're repeatable pieces. They are small sections of code that can be repeatedly what we say called. To be called is to run the function. So the function is basically this piece of code that has a set of steps inside, and it's made so that way you can call it as in run it several times during the program. I'm going to go and erase this. Today's function that we're going to build is going to take one number, it's going to look at it, it's going to take a look at this number, and it's going to tell us if it's negative, positive, or 0. So let's go ahead and start getting that ready. And the first thing I'm going to do is section out the code into a main part of my program and the function. You'll notice I put the function before the main. This helps with calling it. We'll see that in a bit. So down in main, I'm going to start off just by getting a few numbers. We got x equals 7, y equals negative 123, z is going to be 0. Alright, cool. So as you should know, that is a positive number, x is a positive, y is a negative, and z is a 0. But let's get the program to recognize that and actually say something about it. So here's what I'm going to do. I'm going to go back up to this function up here, and I'm going to write the letters D, E, F. And then with a space, I'm then going to name this function. So you know how we name our variables down here? And we give them any name, it doesn't matter, and then every time we use that name, we are using its value. It's going to be kind of like that for the function. So you see the function, let's go ahead and call describe number, and then we put parentheses. Oops. Then we put parentheses, and then inside those parentheses, we're going to put just any variable name, doesn't really matter. And then the next line below, which notice has been indented, it's going to see what that variable actually is. I'm just going to start by doing the a equals 0. Alright, and we'll just pause right there. So a few things are happening here. This is called a function definition. A function definition is where we say we're going to define a new function with a name. We might give it these things called parameters. Which can then be used. And then everything below it that's been tabbed forward is a part of that function. So that if we were to call it down here in main, like I'm about to do right now, we call it by name, we pass it some variable, because notice how there's an a in here? That's just for whatever variable we're dealing with. I'm actually going to change it to value. Actually, since it's described number, I think I'm going to change it to number. What I want you to get out of that is that there's no difference with whatever I name it. It does not matter what you name these variables. Just name them with things that will help you remember what they are and then be consistent. Alright? So anyways, down here I'm calling our function because I'm using its name and giving it the correct arguments. Alright? So one argument for one parameter. Notice how it's the same number of things. If describe number wanted 2 things, I would give it 2 things. Right now we're dealing with a 1 argument function. So I'm going to go ahead and run this. And what should happen is it should pass the variable z, which is equal to 0, to the function described number. Since that z is indeed 0, it should tell us that our number is 0. Meanwhile, if I were to pass it x, you'll notice it doesn't say it because it's not equal to 0. Let's go and add in those other parts. So we add in numbers if number is greater than 0. Let's go ahead and say your variable, your variable, which equals that is positive. There we go. Alright, looks a little confusing. Just remember, include that string conversion in there. Alright, and then I'm going to copy that. Else, because if it's not negative or 0, then it's... if it's not positive or 0, then it's negative. Alright, and hopefully you can see how that works. This if structure is pretty straightforward, I would think. Hopefully. But the function definition, notice how it takes in one number. It has one parameter requirement. When we say parameters, we're talking about what it requires. Arguments are the actual values passed to the program. It's kind of a minor distinction, but it is one I do want you to hold on to. That parameters are the requirement, that's the required pieces of data for the function, and the arguments are the actual values passed to it. So in this case, x is an argument, number is the parameter. Let's go and run that, and oh good. Yeah, notice how it identifies which variable we passed it, and tells us that it's positive. And if we were to try with y, we get the same kind of thing. So yeah, the use of a function is just in how you can segment code and have repeatable options. Later on when we add in loops, this is going to be especially helpful. But for now, hopefully you're thinking of ways that you can start to use this. So let's look at another example. Where in the last one, I know we did some kind of a basic thing with math. And this time, what we're going to do is we're actually going to do an equation and get a value from it to introduce what return is. So let's go and divide up our program, function, and main. Down in main, I'm going to go ahead and get two pieces of data you might be familiar with. One's going to be radius, and the other is going to be the height. And yes, indeed, we're going to make another surface area of a cone program. This time, we're going to use functions, and we're going to use the right formula. It's going to be great. So when we get to this part here, where we're actually going to deal with the getting the surface area itself, how are we going to do that? Well, I said we're going to use a function, so let's go and start off by trying that. Going to go and define, and I'm going to call this function get surface area. And it will, of course, take in two variables, radius and height. Notice this time I named these with the same names as this. That does not matter. I am only naming these R and H because it makes sense, because that's radius and height. They do not need to match the names of your variables. But I do need a colon and then a new line with the indentation there. Alright. So let's begin. The idea is going to be that we're going to put our calculations up here and then call them down here. So to actually get it, it's pi times radius times height plus pi times radius squared. So when we write that out, I'm going to go ahead and shorten pi down to just 3.14. So I'll make a new variable called SA equals. Now I know we already have a variable for surface area down here, but that variable does not exist inside here because it comes later in the program and because it's not inside the function. Whenever you have a function, the only data that it knows exists is within the function itself. So anyway, surface area is going to be set equal to 3.14 times r times h plus, and I'm going to make that a little tighter. There we go. Okay, plus 3.14 times radius squared. Perfect. Okay. And then I'm going to write the word return and then put my surface area variable right there. And down here, I'm going to set surface area equal to get surface area, passing it r and h as arguments. So remember, the values I'm passing here are arguments, the parameters are the requirements, and they must match. So I set surface area, the variable, equal to that function itself. Now when I do that, it basically is setting surface area equal to whatever I return up here. Let's say instead of returning the surface area, I returned a -6. Something like that. Well, in that case, it would only show a -6 down here. But I'm not. I'm going to return surface area. So I get the surface area, and then I print it out. And let me go ahead and add in, what it actually is. There we go. Makes sense, right? I want to go ahead and print it out. I want to get the surface area. Let's try it. 6, 10, 301.44. And if we were to test that out, oh, right, good. So, we're all good on that. That is how we can use this return for our purposes. And notice how much cleaner this looks. This is especially nice if you have to use it repeatedly, because that's kind of the point, is to have repeatable sections. Once we jump next into, I think by the time we're doing the word shift, it should make sense how we can repeat it, how it's kind of useful, how it's nice to not have to copy and paste it several times. But I guess if we wanted to, we could go ahead and augment this program by making it take in, or allowing it to take in, multiple cones. So to get our surface area of a cone, we know that this is the function. Well, let's go ahead and run this, and now you'll notice that it can take in multiple pieces of data for multiple cones, giving us different values every time. And each time we didn't have to recopy the formula, we just had this. And hopefully you see how it has some amount of flexibility. There's some amount of cleanliness to having it just being set equal to this one function instead of all this. In case it doesn't look clean enough though, what I could do is remove this variable here and instead just print out the function itself. Because you see, when the function returns something, it basically replaces it here. So just like how we can set a variable equal to it, we can also just print it out as is. If I were to run that, and just start off 4 and 2, notice how it gives me the same surface area down here? It's very useful to us to have stuff like this. Again, maybe this won't be as useful to you until we get on later, because as you might notice, this is a single line. But start thinking about how we can use this more, especially with this next lab. Alright, well, let's go and jump into the next thing.